Okay, as some of you know, I have just finished up work on my Subaru. The AC system had a leak in the low pressure line. I also replaced the accumulator. That's in a separate video. I'll put a link down below if you want to see the details on that. But I thought it would make a completely separate video on the evacuation and recharging of the system, because I feel this information is pretty much across the board as far as AC systems go. There are very few things in AC that like cross over, but this is one of those things. So I'm going to go through the process step by step of what you do if you've got a completely empty AC system, okay? As far as recovery goes, if you've got some refrigerant remaining in the system and you've got to, like, say, replace a compressor or something, I would urge you to take it to some facility that has an evacuation machine that can actually suck all the refrigerant out of the system, so that you're not releasing the refrigerant into the atmosphere. That's key here. You don't want to just let this stuff just like go off into the atmosphere. You want to be responsible about it, because I mean, it is a CFC, it is one of those things that eats up ozone layers, things like that. So we keep the tree huggers happy. Let's suck the system out, make sure it's completely empty before we open it up. Once you've done that, made all of your repairs, next step, which I'm going to show you right now, is you need to put a vacuum on the system to remove all the moisture before you charge the system. So you've got to evacuate it first, and for that we need a vacuum pump. Let's go see what one looks like. I'm going to derail you a little bit. Now, if you're going to do any kind of AC work at all, it's a must that you've got to have a set of manifold gauges. You're not going to be able to do any diagnosis. You're not going to be able to recharge it. Well, there are some of those kits out there that, you know, just have that little hose that goes in to top off the system. Come on, no. I'm just going to come out and say it. That's a hack way of doing it. The best way to do it is with a manifold gauge set, because these pressures are everything when it comes to AC. They tell you what's happening in the system. So you need a set of manifold gauges, and you start off by, okay, you got the gauges here, turn these all the way to the right and close them off. These are the valves that open and close these lines. So this is the manifold here, and this is going to tell you the pressure on the high side is the red, the low side is the blue, and that's where you hook them up. And in fact, with 134A systems, they made it really convenient to hook these things up. Now, I've already hooked up this vehicle. If you're not familiar with these gauges, what you do is, this is to disconnect them, is you twist these little nuts counterclockwise. You find the high and low pressure. The high is going to be the bigger one. The low pressure is going to be the smaller one. Low pressure sucks into the compressor. High pressure comes out this way. I've done a video on basic AC operation. I'll put a link in the description so you can see basically how an AC system works and understand the reason why you have a high and low pressure. But what you do is this is like a little coupling. You just take the coupling, push it down onto the fitting, let it seat. Once it's hooked on, this is the part where I want you to be careful, because some gauge sets, some manifolds, if you run these down too much, you can actually bend the Schrader valve that's down in here. So what I do is I just keep turning this down. I know that these won't do that, but I just would keep turning this down and keep an eye on the gauges. And once I saw the gauge move or bump, I knew that the Schrader valve was open, and that's all I needed, was to know that the Schrader valve is open. So if you have a set that sometimes bends Schrader valves, or every time you do AC work you find you got a leak, about 80% of the leaks I find in AC systems are actually here at the Schrader valves themselves. So that right there causes a lot of leaks. The same kind of thing like in a tire valve. Same here with the high pressure side. Sort of push the fitting down on there, turn it clockwise until you see the pressure bump, which I won't on this because this is already completely empty. So there, you've got your gauges and everything hooked up. You're like, Eric, what's this one for? Well, this is your way into the system. You would either hook this up, like, say, if you're going to evacuate the system, you would hook it up to a machine that would evacuate it for you, or you would hook it up, like we're going to now, to a vacuum pump. And then, finally, the refrigerant itself all goes through this line into the gauge set. And that's pretty much the heart and soul of this whole system. These little tips on the side here are so you can actually take your leads here, your ends, and hook them on to this so that it stores better. But I just hang mine up on the wall and it doesn't matter. But that's what these over here on the side are for. They're just there so you can hang your gauges. They do nothing. So don't pay attention to those. All the way closed, hooked up. Now we're going to go get our vacuum pump. Okay, this is my vacuum pump. It's a relatively inexpensive vacuum pump, and I had to put a little bit of oil in it. It's an electric motor that basically sucks, haha, and pun intended there. It has ports on the side here. It has two. I know that this one on the side is the one that actually fits my manifold gauge set. And just as an FYI, on the tip of my guy here, the O-ring down inside that wasn't there. So that O-ring was not present when I first started using this. And that's important because it was allowing it to leak right here. So if you're checking for leaks, you're going to close these gauges, and that's going to basically isolate the system and cut this part of the hose out. But I was noticing I was having a leak right here, and it was causing me problems. So make sure you do have seals inside these components, and make sure that they actually do seal something. So I'm just going to hook this up to the vacuum pump here. Just screws on like that. Now with AC stuff, don't try to tighten it so much. Don't grab a pair of pliers and squish this down. Let the O-rings do their work. Just do it just enough to where you know that it's seated up against there. Now I've got to plug the pump in. Okay, I've plugged my pump in and we're ready to go. And quite simply, all I have to do is turn it on and it will begin to work. But coming up here to the gauges, you'll notice nothing's happening. Nothing at all. In fact, everything is pretty much zeroed out. You need to open the gauges in order to let the vacuum get into the system. And you open up both gauges to do this. Hear how it's changing? Same the high pressure side. There we go. And now we are putting a vacuum on the system. So I'm going to actually let this sit for half an hour. I'm just going to let it, well, actually I don't really have to this time because I did have a vacuum on the system before, but I'm just going to let the system run for, I would say at the very least 15 minutes. The optimum would be run it on a vacuum for at least a half an hour. All right, and as you can see, this gauge is pegged out down below zero. About the most vacuum you're going to get is 28 inches of mercury. You might get a little more. A perfect vacuum is 30 inches. It's theoretically not possible to gain that here on the planet. But basically what we're doing is removing the atmosphere. So we'll come back in a few minutes and recheck things and go to step 2. Well, whatever step this is, I'm kind of losing track. But go to the next step, that's what we'll do. Okay, it's been about half an hour. It's time to shut off our vacuum pump. But before I do, I'm going to close the valves on the manifold gauge set. Turn them clockwise. Close that one. Close that one. All right, now that the pump is off, I'm going to verify my repair. Now that the gauges and everything are closed, I'm just going to let it sit with the gauges closed for about another half hour to make sure there's no leaks in the system. Once I'm assured there's no leaks in the system, then I can charge it up. So first you want to remove the moisture by evacuating the system. Then you want to let it sit to verify that you don't have any leaks. Don't have any leaks, then it's time to charge. See you in about a half hour. It's been, well, maybe a little more than a half hour. I actually went and did some other work. But as you can see, that needle hasn't moved a bit, and that's a pretty clear indicator that you don't have leaks in the system, and it's time to charge it up. This is the exciting part. Now that I'm about to charge, I can disconnect the vacuum pump. If you replace like a compressor or a condenser or some major component within the AC system, you may have to add a little bit of oil to the system. And you would consult the service manual to find out how much oil needs to go in with a given component replacement. I just replaced the receiver dryer and a low pressure AC line with this. There are AC machines out there that actually add oil along with the refrigerant charge, which is really nice. You don't have to worry about it. So if you need to add oil, this is what I do. At least with this setup, with just a straight up manifold gauge setup. Is you can take this center hose and you can actually dump the oil into this hose because it's going to be drawn up into the system. And right now, everything's sealed off back here, so you don't have to worry about it. But here's something else that you can also do, which I am going to do now, and that is get some AC dye. Now this is a lot. This is probably enough for like 5 or 6 cars. You do not need to use a lot of this. But what this does is it will permeate the entire system, and if there ever is a leak in the future, this will leak out along with refrigerant, and you put on glasses similar to what I have here and go around with an ultraviolet light, and you can actually find a leak this way. So I usually add a little bit of dye whenever I charge a system, and sometimes you'll find refrigerant that actually comes with dye in it. And it's real convenient for situations like this. So if you have a leak, a really small leak that's difficult to find, this dye is a great way to find it. There's also refrigerant leak detectors, which is actually in the other video that I did about this. But what I'll do now is I'm just going to add a little bit of dye to the inside of this hose. Like I said, you don't need a lot. And honestly, I already added refrigerant oil. The last time I did this, I just added a little bit. So I'm not going to add any oil, but this is where you would add it, and you'd have to measure it out and all those kind of things. Adding oil is really tricky. AC work is really tricky to be done properly, but a little bit of dye down in this, we'll call it a suction hose. I'm not really sure what to call it, but this is the supply hose to the manifold gauge. I wish I knew a name for this. If you know it, put it down in the comments. Anyway, the middle hose, a little bit of dye before you add refrigerant. Okay, before we grab our refrigerant, we need to know how much to put in. Every car with an AC system has one of these stickers somewhere, or should have one of these stickers somewhere, that tells how much refrigerant the system holds. And in this case, it's 19 to 23 ounces, or 0.55 to 0.65 kilograms is the amount of refrigerant that needs to go into the system. So this way you know with the capacity of the system. You do not want to overcharge the system. That would cause just as many problems as undercharging it. In fact, in some cases it might cause more. So the first thing to do is find out how much you need to put in. There should be a sticker under the hood somewhere. Mine is right here, 19 to 23 ounces. I'm not advertising for these people. I'm using this because, you know what, most of you out there have access to this. But this is how much is in this can. It just so happens that there's 19 ounces in this can. So this whole system would be charged up completely by 1 can of this stuff. Awesome, real happy about that. So all I really need to do is add 1 can of this. Now I've already got the, I don't know what you would refer to this as on this can because I already put it on here. But the way this works is you've got to start out with this. I can't open this now because I don't have a hose attached. But you'll start with this gauge, if you want to call it that, assembly screwed to the top of this can because the can won't come like this. In fact, I think I have another can that I'll show you. You screw this down, and then you make sure that this is all the way up. Then you screw this down inside the can, and as you do that, it will pierce the top of the can. Then you have to back this off again in order for refrigerant to start to flow out of it. Once you've got your can prepped and ready, it's time to hook it up to the center hose. And the same hose that you use to hook up to the vacuum gauge, once again, make sure your O-ring's down in there. Or your vacuum pump. The same hose that you hooked up to the vacuum pump, you want to hook up to this now. Make sure it's secure, but not so tight you're gonna kill it. But right now this valve is closed because it's got like a little pin that goes down to the top of the can to pierce it. So now I need to open this back up. So I'm just gonna gently turn this out. And I should have mentioned earlier, pretty much before you get started with any of this, and you see me wear throughout this entire video, safety glasses. If you're working on AC systems, you really should be wearing your safety glasses. All right, I'm hearing a little bit of leakage out there now. Okay, so now the valve is open. So this is the way it would normally come. You'd run this down. If this was a brand new can, you'd have to run this all the way down to pierce the top of the can and then back up like this with the hose attached, because if not, refrigerant's gonna go spraying out everywhere. Now I've got our refrigerant hooked up. Let's start the vehicle. Okay, I'm going to use the vehicle's AC system to draw on the refrigerant. And in order to do that, I need to get the compressor to run. And the compressor won't run initially until I start getting a charge in the system. But since I've got a vacuum on there, it will start drawing the refrigerant in there. So I'm going to start the car, I'm going to turn the AC on, I'm going to put it on the vents. And actually this is what I'll also do. I'm going to go grab my thermometer so we can check our performance. I just went and grabbed my AC thermometer here, and I'm going to stick it in the center vent. This is traditionally where you take AC temperature. In fact, I will post the video link to a video that I did about checking AC performance using this very same thing. So the first thing to do when you're checking this is you want to note the temperature. And right now it's a really nice, like 72, 73 degrees Fahrenheit. And I'll start the vehicle. I'll also turn my fan on. And I'll go on vents. Turn the AC on. So my AC's on, my gauge is in here, fan is on, and actually you just want the fan on low to do your performance check. So it actually got hotter. Alright, now let's charge the system. Alright, the engine's running, my refrigerant is charged, ready, open, connected to the manifold gauge set. You want to charge on the low side. Do not open up the high side, just charge on the low side. And all you're going to do is just open the valve and it'll start to draw it in. I'm going to give you a close-up of the gauge set as soon as I finish here so you can see what I'm doing. In fact, I'll do that now. Okay, my refrigerant's ready. Remember, do not charge on the high side, you charge on the low side. So open up the low side valve. Then you see it got a little bump there, and it's starting to draw refrigerant in already. In fact, I can turn the can upside down to make sure that happens. And you can see the needles start to go up on this side, and it will also start to go up over here. And there goes the compressor, it just kicked on. You can see the refrigerant flowing through this sight glass here. You can actually see the refrigerant going in. I can also see that the compressor is kicked on and my cooling fans are on. All these are good signs. You can tell because the front of the compressor is now spinning and it wasn't before. Now to make sure this stuff is going in, I'm going to turn the can upside down and shake it a little bit. Also want to make sure this fitting is tight. And I know I'm going to take this whole can, so I'm just going to let the whole thing go in. I still feel that there's some weight here. Compressor kicked off. That's actually a good sign. It should cycle. It shouldn't be on all the time. Sometimes it is on all the time. There it goes again. So now it's cycling on and off like it's supposed to. My can's feeling about empty. Yeah, this thing, virtually empty now. So now that I know my can is empty, I'm going to close off the low side on the gauge. The gauge is still going to continue to read. It just won't be sucking in refrigerant from this hose anymore. Now I'm going to guess and say that this is the part that you have the most questions about, and I'm afraid to tell you that there's not much I can offer here. It's going to take experience to figure out exactly what the pressures need to be, because the pressures will vary depending upon what the ambient temperature is. So the hotter it is, the more humid it is, the pressures are going to change. But right now it's actually a very cool day. It's really not a day where I can say that AC is something that you really need. So I'm not surprised to see this cycling on and off and seeing the pressures that I do here. But on really hot days, what I usually see is the compressor stays on continuously and you get actually a higher side high pressure. Right now, we're right around the 125 mark, which seems a little low to me. And then the low side goes down, the low side looks like it goes down to about 0. This gauge has several different measurements on it. It measures in inches of mercury, it measures in bar and something else. I'm going by the inches of mercury in the center of the high pressure gauge. And on the low pressure gauge, I'm going on the outer, which is a scale that's specifically for 134A. But this on the inside here looks like the inches of mercury, just like this. So right now, it's dropping down to 30, 20, but once that gets below 20, it should shut off. Or somewhere, yeah, right around there is about where it shuts off. But the high pressure is just as important as the low pressure, and I'm not going to get into AC diagnosis. I'm just going to give you a general idea of what you're supposed to look for when you charge the system. Inside the car, this is what we're seeing. I'm seeing it drop down to, looks like about 48 or so. It's actually nice and chilly. But you don't need to put the fan on high when you do this check. Actually, low is fine. But if you want to feel the full effect, oh, and the other thing is, you don't put it in recirculate, just put it in fresh air. That's the best way to check the performance of the AC, because you're actually cooling the outside air. When you put it on recirculate, you're actually cooling the inside air, which works great for cooling the inside of the cabin, but it's not the best way to check the performance. I have seriously cold air now. Let's wrap this up. Okay, I'm going to take my gauges off now. This is normal. It should quit. It's just a little bit of refrigerant just sort of boiling out of this area. It should stop. If it doesn't stop, you might have a problem. Reinstall your dust caps. All right, let's wrap this one up. Safety glasses, wear those. Manifold gauge set is a must. If you're going to charge the system from empty, make sure you vacuum it down. If the system has been empty or open to the atmosphere for any length of time, particularly in humid climates, replace the receiver dryer or accumulator assembly depending upon what kind of system you have. The pressures that you're looking for vary greatly depending upon temperature. There are charts out there that tell you, in fact there might even be a chart on the back of this one. Yeah. There's a chart on the back of this thing here that tells you roughly what you should see as far as the temperatures go. It doesn't give you any high side readings, which in my opinion high side readings are equally important, because that tells you how well the condenser is functioning and how well it's able to transfer heat. See that video on basics of AC operation for a little more information on that, because basically you're taking heat from inside the cabin and putting it outside here in front of the radiator. That's basically what an AC system does. So the high side pressure is equally important. And I've seen high side pressures on hot days go above 300 PSI sometimes, because it's got a higher heat load is what that's called. So as far as pressures, I might dig around on the web and see if I can find an article or something like that I can post a link to. I'm trying to give you the most information possible, because to me, AC work is not for the faint at heart. It's not for the amateur. You really have to pay attention to what you're doing. And even professional technicians have trouble with this sometimes. So it involves so many things. I mean, it involves the pressure temperature relationship. It involves mechanical components. It involves electronic components. Then you've got the entire HVAC assembly that could have issues going on there. So you really need to have a broad understanding of all those different components of the system in order to properly service and repair it. But if you wanted to recharge it, you replace the component. Like I said, you can add your oil into the third hose here. You could also add like any AC dye or anything like that to that to get that to go up in there. And I'm going to stop talking now. I am Eric the Car Guy. You can always find me at EricTheCarGuy.com, or you can find me on Facebook, Twitter, and Google+. And around here I close with be safe, have fun, and stay dirty. But today I'm going to add one more. Stay cool. Catch you later, everybody.